This video is on the objective solve linear trigonometric equations in cosine. And this is number 2, the second video on this objective, so hopefully you've seen the first one. And it's going to be very similar. So let's take a look. So again, if you want to see more about the topic, how they're doing things, how they're teaching you, click on more instruction, look at their videos, their notes, their examples. Hopefully those help. Alright, so here we're asked to solve this equation, right? 1 minus 7 times the cosine of theta equals 8, right? Find the values of theta that make this a true statement. But they're only asking us for the values of theta from 0 to 2 pi, right? Not including 2 pi. Alright, so I'm going to go about this the same way I did in the first video, the same way I've been doing, did in those sine videos as well, where I'll write out the general solution, list a bunch of them, but then we'll figure out, what are the only solutions that are actually in this range from 0 to 2 pi that they want. Alright, so the equation in question is 1 minus 7 times the cosine of theta equals 8. So I'm going to isolate this cosine of theta. Alright, just get the cosine of theta alone. So to do that, I'd first subtract 1 from both sides, giving me negative 7 times the cosine of theta on the left side equals, and then positive 7 on the right. And then I would divide by negative 7. So that leaves me with this. Cosine of theta equals negative 1. Alright. Alright, now, again, negative 1, that's a nice number, like square root of 3 over 2, square root of 2 over 2, a half, 1, 0, negative 1, This is a nice number. You should know angles that have a cosine of negative 1. Now what I'm doing here is I'm thinking of going, I'm just going around the unit circle one time. Just go around the unit circle one time mentally. And think of what are the angles, if there are more than one, that have a cosine of negative 1. Right, so what I'm going to do next is state the general solution to this equation. Now again, thinking of going around the unit circle one time, there's only one angle I can think of that has a cosine of negative 1, and that's pi. Right? The cosine of pi radians, or 180 degrees, was negative 1. So it's going, to pi, right? It's going there. Now remember, you can keep adding 2 pi from that, subtracting 2 pi from that, and ending up at the same place. So if I want to describe all the infinitely many values of theta that'll make this true, I can throw on add to pi, add 2 pi times k, add on any multiple of 2 pi, right? Again, k here is an integer. And this is it, right? Like I said, pi is the only angle when you go once around the unit circle from 0 to 2 pi that satisfies this equation that has a cosine of negative 1. So here's the general solution, right? A description of all infinitely many solutions. And then what I'll do is I'll list a bunch. Here I'm going to list some solutions. Again, I like doing this. You don't have to do all this. You can probably already tell me, hey, pi is all they want, right? They only want the solutions, they only want the values of theta that make this true between 0 and 2 pi, and that's pi here. Alright, so again, I like to put in different values of k. K is 0, 1, 2, whatever. k equals -1, and so on. And when k equals 0, we're getting pi as a solution. And then going in both directions, I just keep adding 2 pi or subtracting 2 pi. So like going this way, I'm adding 2 pi. That 3 pi would be a solution, 5 pi would be a solution, 7 pi would be a solution, 9 pi, 11 pi, and so on. Going this way, when k is -1, I'm subtracting 2 pi. So -1 pi would be a solution. -3 pi would be a solution, when k is -2, and so on. And again, I could do that all day long. These equations, these trigonometric equations, when they have solutions, they're going to have infinitely many in most cases. Well, there's a bunch. Here I've just listed 5 solutions to this equation, but they only want, right? We want just the values of theta between 0 and 2 pi. And if you look at any of my solutions here, these solutions here are too big. These solutions here are too small. The only one that works that's also within this range is pi. All right, so theta equals pi is the only solution we're going to be asked to find. Right? Even though there are a bunch more, right? There's infinitely many. The only one that's in the range they asked us for is the number pi. So that's this first option, right? Theta equals pi only. Answer's good. Great. Wonderful. All right. So hopefully watching me do this, looking at the more instruction, looking at your answer explanations, hopefully all this stuff helps you out when you're working on this assignment on your own. And thanks for watching.